Partial fraction decomposition is basically the reverse of the problem that you see on the board right here. It's our way of figuring out the numerators. So if we were to look at this problem and not know the numerators and kind of know the end of it, we would be able to use partial fraction decomposition to do it. So in order to really understand what we're doing, let's go ahead and actually figure out what this would be. And so we'll start by just getting a common denominator. Our common denominator is x plus 3 and x plus 5. And that means we have to put it on both of them. So this is just a review of some old algebra stuff that you should already know if you know how to integrate. From here to here we multiply by x plus 5, so we have 4. And then we'll put that times x plus 5 because that's what we put in the bottom, so we have to multiply on the top. From here to here we multiply by x plus 3, so there's a 1 times x plus 3. And then our final answer is going to be, well, this common denominator, x plus 5, and then we're going to have 4x plus that x, so 5x, and then 20 plus 3, so 23, and there we go. We just went forward with the process, and now we're going to go backwards. We're going to do a problem where we don't know the numerators, but we do know the denominator, and the denominator does factor. If the denominator doesn't factor, then we can't do this. But I believe we can do the next one, and the next one looks like this. Let's see. I'm going to find the partial fraction decomposition for this. Let's suppose someone gave you this one right here, and they said, hey, I want to break this down into two fractions. Well, what two fractions would they be? Well, I'll tell you what two fractions they'd be. Maybe that and that. Well, that was vague. Well, this does factor. It's going to be x plus 3 and x plus 1. And I don't know what's up here and I don't know what's up here. So basically this is the problem we just did. Now we're just kind of undoing it. Now on this problem we have a number. On the last problem we had like 5x plus 23, but that's okay. So I don't know what that is. I'm going to call it big A. I'm going to call that big B. They usually use capital letters for these. Don't know why. Okay, so looking at this and knowing that what I just did is going to help me in this process, then let's do it. So what I really have is this, and you may not want to write everything that's about to happen here long term. You'll get the hang of it. Nevertheless, I think you'll kind of see where this is going if we write it at least this time. And it's this right here. So my common denominator would be x plus 3, x plus 1, and x plus 3. X plus 1 in no particular order, and this one was an A and this one was a B, so this is mathematically incorrect. If we changed this denominator by multiplying by x plus 1, then, well, x plus 1 would go here. If we change this one by multiplying by x plus 3, then, well, x plus 3 would go here. Okay, so what we really have here is an equation that is purely fractional, a rational equation. We have lots of fractions in our equation, and we can wipe out the denominator. So technically, in effect, what we're doing is this, and I'm going to show it this time and this time only. If we multiply by x plus 3 times x plus 1, they would cancel. And we multiply by x plus 3 times x plus 1, then they would cancel. And then we multiply by x plus 3 times x plus 1. Every term gets multiplied and they cancel. From here on out, I'm not going to do that. I'm just going to mark out the denominator. I'm going to solve that numerator. And how am I going to solve that numerator? Well, I want to find out what A and B are. So here goes. 1 equals A, x plus 1, plus B, x plus 3. Okay, so we have three variables here. We have A, B, and, well, x. Now, knowing where this is going, we're going to be integrating some function where x varies and x changes. We can pick what we want for x. And at this point, we don't have a denominator that would say, well, you know what, x can't be -1. Well, whatever. Yeah, it can. If x was -1, that would make my life so easy if I was to solve this. So I'm going to come over here on the side, and we're going to do that. We're going to say, well, you know what, let's suppose that x was -1. And I picked that to make this term go away. So I'm going to do some stuff in my head, but I think you know where this is going. This pen is not working too well, but that's okay. It's a marker, not a pen. If we had a -1 here, then we'd have A times 0. Okay, so we don't have to deal with the A, but this is going to help us find out what B is. So 1 equals, and then we're going to plug a -1 right there. So when we plug a -1 right there, we're going to have, well, -1 plus 3, so 2, and that's equal to 2B. Well, that's great. Now I know what B is. B is 1/2, and I'm writing it with a bad marker. Okay? So now we're going to figure out what A is. Well, why don't we pick an answer or pick an X value that'll make it pretty easy for us to figure out what A is. which means we can wipe out b by putting in a -3. So if we put a -3 right here, then b is gone. So let's plug a -3 right there. So if x equals -3, then we'd have 1 equals a times, well, -3 plus 1, so -2. I should have written -2a, but that's okay. A equals -1/2. Fantastic. Okay, I know what a is, I know what b is, and we're going to go from there. And when we do that, what we're going to have is essentially back to this. The partial fraction decomposition really means I want to add two things and get that. Well, what are those two things? Well, the two things are this and this. And so here it is. Final answer is going to go right here. A over x plus 3 plus b over x plus 1. And if I was to do all the math on this, I'd get that. And I would take the time to show you, but I don't want to. What I am going to do instead, though, is clean this up a little bit because people mostly don't like that. Most people will probably put this one first because it's positive. That's just a matter of preference. And most people are going to take this 2 and slide it down to the denominator because it's really the same thing. So you have a 1/2 in the numerator. You really have 1 over 2 of those. So I'm going to do this. I'm going to make it -1 over 2 x plus 3 in parentheses. And then you can distribute if you want to. And then 1 over 2 and then x plus 1. And if we were to do all our mathematical magic, it's not magic, it's just math, we'd end up with that right there. Okay, well the next problem is really interesting because it tells us to integrate that exact same thing. So here goes. This is where this whole thing is going. So far there's no calculus, right? This is like hardcore algebra. So here's what we're about to do. I'm going to keep that right there. I'm going to erase this too. I don't need it. So this is really the integral. Make that a dx. And I want to find out what that is. Okay, when I first see that, here's my first thought. Every time I see an integral, I use u substitution, at least in my head. So I'm like, well, u equals x squared 4x plus 3. U is usually the denominator, right? So that's your first guess. So du equals 2x plus 4, and then dx, and I need a numerator. Oh man, I don't even have any of that. So I don't have an x up there. I don't have none of that. So that's terrible. It's not going to work. So u substitution is not a thing I know. I will try integration by parts. Okay, fantastic. Then you're going to have to identify u. You're going to have to identify dv. What? No. What components do you even have? No, that's not going to work. So I recommend that you use partial fraction decomposition. So this is another strategy we have when a lot of other things don't work. And it works well when you have, well, fractions that need to be decomposed into their component pieces. So this is really equal to this. Now, if I had just given you this problem, we'd have had to go through all that stuff to get this. That'll happen in the other examples, but we've already done the work. So this is really the integral of -1/2. I'm going to go ahead and squeeze it in the front there. And then dx over x plus 3. So just taking the -1/2, putting it in the front. It's perfectly legal. Do it all the time. And then 1/2 integral of dx over x plus 1. Everything I've written here is perfectly valid because this plus this equals that. So we're just breaking it up into its component pieces. And now we'll just integrate. And this is like u substitution, but the really easy kind because the derivative of the denominator is 1, so it works out. So we have -1/2 natural log of x plus 3 plus 1/2 ln x plus 1 and then plus c. And we're done, but we're not. So this is good. We're great. It's happy. It's correct. But there's a lot of simplifying we can do, and it'll reinforce our understanding of the properties of logarithms. And I think we should do it. So normally when you're adding logs, you would multiply, and I hear you, but that one's negative. So I'm going to do something that I probably should have done earlier. I mentioned it earlier, but I just never did it. And I'm going to turn this around. So it's 1/2 ln x plus 1. I'm going to take a few steps to really take this where I want it to go. Some people can jump straight to the simplified answer. That's cool. You can do that if you want to. Minus 1/2 ln x plus 3 in the bars, and then plus c. And that's fine. But now we're going to divide. See, because I mean, I would have multiplied, but I'd have been multiplying the negative this, which puts it in the bottom, times this, which is in the top, and I'd get the same thing. It's just weird to think about. So what I really have is, well, 1/2. I'm going to go ahead and factor out the 1/2. Should have done that first. So 1/2 ln x plus 1, and in just a second we're going to divide these. Do it all in one step if you want. That's okay. So factor out the 1/2. And that doesn't always happen on these, by the way. So 1/2 ln x plus 1 over x plus 3, and then plus c. And that's correct. And then, I mean, this is fine. I mean, all these are fine. But let's just make this just as clean as a whistle, which is kind of gross, actually. There's probably some spit in a whistle, but whatever. Anyway, that 1/2 is the same thing as an exponent, and an exponent of 1/2 is the square root. So we really have the natural log of the square root of x plus 1 over x plus 3, and then plus c. And you can't take the square root of a negative number, keep it positive, and have it not be imaginary. You can't take the natural log of a negative number, so the bars are irrelevant. Like, it's kind of like the root replaces the bars. All right? So there is your first example of integration by partial fraction decomposition. I think we have time to go through one more in this video. Let's do it. Okay. So this one's going to take a couple minutes to kind of wrap our minds around and figure out what we're doing with it. Take that dx out of the top there. You can leave it. It's going to be fine. So it's 5 over x squared minus 9. 5 over x squared minus 9, and that's dx over here. Put it in the top with the 5 if you like. Not a big deal. So we're used to taking the 5 and putting it in the front. And you can do that. I choose not to, but you could do that if you wanted to. What I'm going to do here is look at this and try my little bag of tricks. We're going to try it in our head. The derivative of the denominator is going to be 2x. That's not in the top. Maybe it's arctan. Oh wait, no, arctan is added. Maybe it's integration by parts. Okay, well then u is something and dv is something. Wait, what's what? Who knows? So no, we're going to have to use partial fraction decomposition, and therefore I'm going to come over here and do it. So what I really have is this fraction, 5 over x plus 3, x minus 3, and that is really two fractions added together. One of them is something over x plus 3, and the other one is something over x minus 3, and it's a and it's b, and I don't know what they are. Okay, we've only gone through this process once, so I am not going to show all the steps, but I will kind of do a few things. So if I went to the next line, I would have 5 over my denominator. I'll show it. Don't put your denominator if you don't want to. I'm about to wipe them out. And then I'd have x plus 3, x minus 3, and that would be x plus 3, x minus 3, and there's my b here, there's my a here. This is mathematically incorrect because we totally changed this denominator by multiplying by x minus 3. We changed this one by multiplying by x plus 3, and now it is perfectly legal to wipe out your denominators. It's the same thing as multiplying every term by that denominator. We'll use the good pen. The other one's kind of difficult to write with. And so now we have this. 5 equals a x minus 3 plus b x plus 3. And we need to figure out what a is and what b is. And so we just pick, I would say random, but we pick numbers for x, values for x that will make this work. So let's suppose that x equaled 3. Well, if x is 3, this is gone, and b is going to be staring me in the face. So b is going to be, well, 5 equals 0 plus b times 3 plus 3. And so b is equal to 5 over 6. Cool. Let's suppose x was, well, what's the next logical one? Cancel this one. Now let's cancel this one. Negative 3. Okay, so 5 equals, negative 3 goes here, so it's going to be a times negative 6. So a is negative 5/6. And that part would be gone because it's, well, 0. All right, we have now figured out the partial fraction decomposition. The algebra is over. Back to the calculus. We have figured out how to write this now. So a is negative 5 over 6. So negative 5/6 over that. We can do a little bit in our head here. I'm going to call it, we'll put it in the front. Negative 5/6, and then dx over x plus 3. If you're not following what's going on, this is that. Only I know what a is now. And then we'll do the same thing with b. So plus 5 over 6 integral dx over x minus 3. There we go. And we're going to just integrate this. And when we do, we have negative 5 over 6 ln x plus 3, and then positive 5 over 6 ln x minus 3, and then plus c. And we'll do some of the same algebraic stuff we did a few minutes ago. Let's turn them around. Let's factor out a 5/6. Let's do several steps at once this time. Let's factor out the 5/6, and we'll turn them around at the same time. So that's going to go backwards. So we have the natural log of x minus 3. You can skip this step too if you know what's about to happen. Natural log of x plus 3, and then plus c. And then we're going to have 5 over 6 right here, natural log of this divided by this, so x minus 3 over x plus 3, and then plus c. And this is fine, but let's go one more step just because it's fun. So this is really the natural log of the 6th root, and an even root means it has to be positive, so we're going to drop the bars. X minus 3, x plus 5, all that is to the 5th power, plus 3, not 5. And then we will add c, and that 5 looks like it's kind of dangling there, so we'll box it all in so we know where the actual answer is. There it is.